Hello everyone and welcome to my YouTube channel. In this video, I'm going to show you how you can use Nightlight data from Google Earth Engine to create your own visualizations, to visualize your region of interest and how Nightlight has been changing for quite some time. So in this tutorial, I would like you to go to make sure you have signed into your Google Earth Engine code editor. And so what you need to do is here in a new script, just go under your search bar and then type in Nightlight. So Nightlight is going to show some kind of data sets that are available in Google Earth Engine, and so these are what we are going to pick from. So if you look through the list of rasters, you can see that we have several Nightlights, but what I'm interested in is the daily gridded raster, not that one, but the nighttime, day and night band composite version 1. So I'm going to click on this one, and so when you click on that one, I think I need to disable my light mode, my dark mode extension. So I'll just go to my extensions and then click on my stylish extension and disable this one. So I'll come back to it later. So I just want you to open this VIIRS Nightlight or nighttime, day and night band composite version 1, and you can read through the description here. You can also look at the bands. You see you have several bands, but we are only interested in the average radians, which is average DNB radians values with -1 minimum, -1.5 minimum to a maximum of almost 300 nanowatts. So this is the units that are used to measure the average radiance of this night light. So this is the code snippet, but before that, let's go through some description. So here you can see it says that this is the monthly average radiance composite images using nighttime data from the visible infrared imaging radiometer suits. So this is the short form or for the data set. And so they say as these data are composited monthly, there are many areas of globe where it is impossible to get good quality data coverage for that month. So that means that even if we are going to work on this, there are some areas that maybe the data was not captured during the night, and so we shall just work with what we have. I think that is what they are trying to tell us. So they say that this can be due to cloud cover, especially in the tropical regions, or due to solar illumination as happens toward the poles in their respective summer months. Okay, so those are some of the factors that perhaps they consider will be the problems that make them not to collect data, let's say maybe for a specific period of time for a specific location, especially in the tropicals. So the tropicals are maybe those areas within the tropics, so the areas within the tropics. So therefore it is recommended that users of these data utilize the CF/CVG band and not assume a value of 0 in the average radiance image means that no light were observed. Then there's also some cloud mask which you can also read through in, but we are not interested in that. We're just going to have a simple night visualization of our region of interest. So for that case, I'm going to copy this snippet here, and then I'm just going to close. So here I will turn back to my night or my dark mode, I mean. So I'm going to click here and then I choose this one for my dark mode. So I'm going to say variable, the variable name, which is the VIIRS, is equal to, then I'm going to paste the image collection as that. Then also I'm going now to select the band. So here I'll go into a new line and say dot select, and I'm going to select the band, which is the average or AVG underscore radians, that way. Then I'm going to define the region of interest, so the region that we are interested in. I'm going to say variable, and then I'm saying region of interest is equal to a table, and this table is going to filter. We're going to filter bounds, and then we shall say geometry. We have not created this one yet, but we are going to do that just in a second, but for now I'm going to click on Control S and save my work. So here I'll just say practice underscore night light. Okay, then I'll click on OK, like that. And so this is going to save our work, so that if by chance we move out of this window, we are okay to do so. Anyway, so here I'm going to search for file which will provide us with the global administrative units for level 1. So I'm interested in level 1. So here you can see we have the tables, rasters, but only interested in layers 2015. So if I just going to click on the first version, this one, I'd just like to look at it first. Then so this is 2015 level 1. Yeah, so I'm interested in this, so I'm going to click on import, and this is going to import the 2015 level 1 global administration. So we have our table there, that's why we said the table. And then the geometry is that first of all I'm going to import or connect this one to the map. So what I'm going to do is I would like to add this one to the map. So I'll say I would like to say map. So here I'm going to say map dot add layer, and I'm going to add the table. So I'm just going to say add table. So I say add table, like that. Then for the visualization parameters, I'm going to say this one is going to be empty, and then the region of the name of the layer, I'm just going to say the admin. Just say admin. So click on run. Our geometry is not defined. So here I'm going to comment this one first and then run that. Okay, so we can see the administrations are being added to our map. So I'm interested in the region of interest that is somewhere here in Kenya. This region here. So I'm just going to pick the point. So I'm going to click on add marker. You can see the controls here on your map. So I'm going to click on this one, and then I'm just going to pick this region here. So if I click on that one, then I will get the geometry. So that means now I can even comment and comment the other one, right? This way. And then I'm now also going to say map dot add. So I don't think now if I need to add the whole table, but I just need to add the region of interest now. So I get the region of interest, and then I say this is our region. So I click on that one, and then we get to our region. But now we have not centered the map to the region of interest. It is showing this because we already moved manually to this place. So what I'm going to do is I would like to center the map. So I'll say map dot center object, and then I'm just going to center the region of interest, and the zoom level will be something like 9. Okay, so click on run. Yeah, now we are zoomed to the region of interest, and we can move around. Okay, so I'm just going to remove the point, and also now we can see the region of interest. Okay, so we can proceed with the rest of the work. Now the next thing is now to write a function that will build one annual image from monthly data. So that one I'm going to say function, and this is going to be function yearly night light, like that. And this function is going to take an argument, and that is going to be a year, because we shall be calling several years. So that means inside the function I'm going to say now to declare a year, and say the year is equal to ee dot number, since it will be an integer, So year that we have passed in this one. Remember, this year here is the one that we have passed in as an argument of the function and not the one here. Okay. So next is going to be now to write a variable for the start and end time. So say variable start is equal to, so start time, you can say start time or you can say just start. So is equal to dot date dot and from the year, the month, and the day. So the year will be that year that we have. So the year that we have in the argument, and it will be from the first of year of month 1, which is January, to day 1st of January. So day 1st of January that year. So we don't know the year yet, but we shall see as we proceed. Then the end, so we say variable end is going to be now the dot, no, it's going to be the start. So this is going to be start dot advance. So we shall advance from the beginning towards the year that we want to end. So that one will be from that one to the year. So we shall begin from that year that we already picked to the year that we shall pick as our end. Okay. So also I'm going to declare now the image. So the image is going to be the image collection that we have, and this is going to be it's going to be image is equal to our image collection, which is this variable here. You can just copy that if you don't want to get confused by typos, and you can paste it there. Then we are going to filter out. So we say dot filter date, and the date you are going to pass in the start date and the end date, like that. And then you also say dot filter bounds. So we say dot filter bounds. So we want to get the data of our region of interest. So say bounds, and bounds is going to take in our region of interest, like that. Then we're also going to pick the mean value of or the average value of the statistics that we have in our image. And then lastly, we are going to say clip to our region of interest. So then now we can put a semicolon like that. Okay. So remember, a function must return something. So we are going to say this function should return something. So here we are going to say return. This is going to return an image, and this image will have the year. So we set the year, and the year is going to be year, and also dot set, and we're going to set to the time. So system, this is going to be time start. So the name will be start dot in milliseconds, like that. Okay, since we are creating a time lapse, so that's why we need the time in millisecond. Okay, so I'm going to move out of the function. So make sure you save your work. I'm almost making a mistake of closing the work here. Anyway, so we are proceeding with that one. So the next thing is now to build an image collection for the period that we want to get. So here I'm going to say variable years. So the time that we want to check the time lapse of how the nightlight has been changing for a period of time. So I say dot list, since this is a list of years, dot sequence, and then I pass in the year. So I say 2014 and let's say 2018, like that. And then down here I'm going to say variable nightlight image collection is going to be equal to the image collection. So ee.image collection, and then inside this one we are going to take the years. So we're going to map through the years. So here I'm going to say years that we have listed above, which is 2014 to 2018. So we have 2014, 2015, 16, 17, and 18. So we are going to say years.map through the years using the yearly, the function. So the function is going to run as it maps through the years. So Nightlight. So remember, this was our function. If I just confirm that that's correct, okay, like so. Yeah. Then the next thing is now to confirm that actually data exists in our image collection. So what we are going to do is you can just put some print function here and confirm if actually data exists in our image collection. So we can say image collection size, and then we pass in our Nightlight image collection dot size. So we can call this variable here, and then we say dot size, like that. So this is going to print out the size of the image collection that we have. Otherwise, sometimes you may be doing your work, but you're actually working with an empty image collection. Okay. Yeah. So the next thing is now to create the visualization parameters. So down here, I'm going to say variable visualization parameters params is equal to, this is an object that is going to take the minimum value as 0 and the max value as 60, something like that. Then we're going to pass in the palette like that, and this is a list of colors. So I can say 000, 000, which is black, and then pass some light color, which is FFF, right? So we're going to have a black and white image like that. Okay, so down here I'm going to say I'm going to add the whatever we have to the map. So I say map dot add layer, and then inside here we are going to add the Nightlight image collection, which we have here. So we're going to add it there, and then the visualization parameter is going to be now the palette or the VIIRS params that we have here. So I can say that, but for now we're just going to leave it as empty. I'll show you something in a minute. So here, then we put the name of the layer. So we can say Nightlight time lapse, like that. So ensure you put a semicolon. I'm going to click on run. Yep, and now we have the light for the specific period. So this is like an average or the current period that we have. Yeah, so looking at the base map from our Google base map, this area is actually a city. That's why we have a lot of Nightlight, as you can see. So this is a city, and you also have some areas with big towns, like this one here. You can see we have light. Okay, so the next thing is now to actually export this to a video that will be showing time lapse. I think that is what we wanted to achieve in this video. So here I'm going to say export. So we're going to say export dot video dot to drive. this is going to take several parameters inside. So the first one is the image collection. So the collection is going to be the night image collection, the Nightlight image collection here, and then we say dot map, and then we pass in a function, and this function is going to return an image that we are supposed to visualize during the play of the frames of the video. Okay, so there, I just need to write a function and then say return. So the function is going to return the image that we have just passed in dot now visualize, and the visualize function is going to take in now the VIIRS params that we just declared above. So say VIIRS params, okay, like that, and then we move out of the function which is under collection. The next parameter is going to be a description. So we say description, and description is going to be we can say night underscore light underscore 2014 underscore to 2018. That's just as description. So the name that will appear as our video file. Then the folder, we can also declare a folder, and the folder is going to be GEE, and then we can say GEE time lapse, GEE time lapse, something like that. You can create your own folder in the drive as you like. Then now the frames per second, frames per second is going to be like 0.1. So we're just going to take the least frames per second that we are provided by Google Earth Engine. Then scale is going to be 500, and region, obviously the region is the region of interest dot, then we pick the geometry like that, and then we have the CRS. So CRS is going to be EPSG, and this is going to be 4326. Okay, now the maximum number of pixels that we want to export is so we say maximum number of pixels is going to be 1 times 10 raised to 13. So 1 times 10 raised to 13, like that. So put a semicolon, click on save, and then confirm that everything is okay. Then now you can click on run. So we are still going to see our image here, but now if we go to tasks, you can see we have the Nightlight 1418. So you're going to click on run, this one, and then these are the custom parameters that we have just passed in during the export to drive function. So there you can see we have the folder, as we said, the frames per second 0.1, and then the file name. So click on run. So we are going to give it some few seconds to run and export this video to drive. Okay, so as it does that, I'm going to open my drive. So I'm just going to open my drive and then move to the folder as we expected. So I'm going to this folder here, and I'm going to wait for a video to pop up here. So I'm just going to confirm if everything is okay. Sometimes it fails because of some few challenges. Maybe the image is too big, or maybe some other technical issues with Google Earth Engine, or maybe the internet is not okay. So looking at that, I'm just going to, now it has finished exporting to drive. I'm going to drive again, and I can see that I have Nightlight 1418. So if I double click on that one, it's going to say that I need to download that video before actually visualizing it. So it's going to download, and if I just click on open, and try to see if we can see anything. Maybe I can try to reopen it again. So remember when we read through the description of the image collection, we are told that some of the months do not have the data, but some have. So our video is running, and so up to some point, then we shall begin to see some changes. So that means maybe from the back, let's say maybe for a whole year we didn't have anything, so boom, then you can see that it has actually shown some light there. It's not so visible. You can try to improve on the code and see if you can come up with something very, very visible. I'll be in the comment section waiting for your maybe kind of response if you actually did improve on the code, so that you perhaps you got a clear image that was good to visualize the change. So the change is very, very minimal, and this is it. Just ensure that you try to improve on it. So you can see, if you look here where we have the city, you'll see that some light changes to, you can see it has changed to something else. Then there is another one. So there are some distortions that during export it didn't come out clearly, but you can also look for ways of trying to improve this. I'll be following in the comment section and see what you guys actually got. Yeah, so this is it. I hope you have learned something on how to visualize Nightlight and also export to a video. I'll be in the comment section trying to see if you guys got an improved version of the code or the video. So thank you for watching, and I make sure to subscribe to my YouTube channel. I hope to see you in the next one.